question for you.
Okay.
So this question is not. I mean, I'm not sure if you will get disappointed though. I don't think this question is not that hard. But
That's fine. I don't care if it's
uh,
hard or not hard. Like, I just want to see if I can
but
solve it, I guess. Yeah, I don't think about that stuff.
yeah, but the thing is, if you get it, you will get it quick. But if you don't get it, like me, I didn't get it the first try, so I struggle a lot.
That's fine.
And yeah, and this question is one of the most popular one on Nico, and I hope that you have not yet come across it. But if you did,
Like,
pretend you
I
haven't.
don't try like memorize solutions. So
Yeah, good. So good stuff.
okay,
So um, and sorry once again for the wait because
it's okay.
I
Yeah,
I wasn't planned to go to the office hour today,
yeah,
and the homework becomes really tough. I'm doing a master's in computer science in
yeah.
UT Austin.
Okay.
So yeah, the homework is not that easy. I struggle a lot on that thing. So anyway,
Oh, so given an integer
different
array,
story.
find the so okay. So want to find the largest sums. All right. So so we want to find like any like so so we want to find like any largest contiguous array sum, right? So what we can
Yeah,
say
it's
is okay. So let me think about how I should approach this. So we can say like so like a so like a brute force approach is for every j, and then for every say from 0 to n, right? And we can say like, oh, for every I. I mean, I'm just saying. So what we can do is we can choose every possible pair of 2 points, and if we can find the sum
right.
of that, and if we stick a minimum, right? But we don't want to do that, right? But that's like the brute force, right?
Well,
So
okay. That's a good point. But if you were go with the brute force,
I'm not gonna
what
go
would
with the
be
brute force.
the
I'm gonna improve it, right? So brute force. If we go to brute force, let's see. So there are for every I, right? 0 to j. Then the sum is going to be let's say sum of sums from I to whatever j, right? So how many states are this? Is n times n, and there's also n, so it's n cubed, right? And we take the minimum of all of these, and so you don't want to do that,
okay?
right?
So, yeah, slow down. Can you explain to me where I'm seeing two for loops. Why is NQ?
Because taking the sum here is already O of n, and so this n
Right.
times n
Yes.
times n, so it's n cubed, right? So
Yeah.
we take
Exactly.
the minimum of all of it. So we don't want to do that, right? And so
No.
like another way to phrase this is for every j, so we want to find I say this we want to minimize I actually want to maximize some I with I less than j, such that some of uh some of I guess this is more like a formally I'm saying some of this is maximized, right? This is more like a mathematical uh formulation of this problem. But so I'll try to like reduce this down to O of n. But this is what we're trying to solve, right?
Yep.
And so what this means is so how do you like how do we say this, right? So we can say this is equal to piece of j plus 1 minus piece of I, where we say piece of I could sum of from let's just say from array from 0 to I, right? So I'm trying to slow down here. So pictorially, what does this mean, right? This means that let's say this is I and then this is some j. If I want to get the sum here, the way how I find it is piece of I is a oops, trying to work with this indent. it's like better with a whiteboard. It's sum of all of this. And so if I want to sum of all the intervals, in a piece of j, it's sum of all of this here. So if I want this sum over here, I just have to like subtract piece of j minus piece of I. So let's just say so that's how you get this portion here. It makes sense so far?
Mm-hmm.
And so now that being said, we wanna so how do we maximize this, right? So in order to let's just copy that. So one minus such that piece of j plus one minus piece of I. So now copy paste this here. Oops, is maximize. And so how do we maximize this part, right? So if you want to maximize this part, then you want to minimize this difference here. So we can say now like if you like formulate this equation, so we get this. And say this minus this is well, we want to be able to like turn this we want to rewrite this I in terms of j so that we don't have another inner for looking for this I, right?
Let me try to understand what you're thinking. So your P of Y, basically you're summing everything from the beginning to the ith index, right?
Yeah.
And then the sum of from I to j is basically the okay, yeah, P of j plus one minus P of okay, yes. And yeah, you're thinking too fast. I have to catch up with you. So
Sorry. Yeah.
for every j, we want to maximize some I. Okay. So basically, 36 is so these two lines is same as the one above. These two lines above, right?
Yeah. So
So
I'm rewriting this in terms of this here, right? So that this is not all of n operation. This is all of one operation.
Oh yeah. So you're trying to like reduce from
N
but big
squared
of
to
n.
n, right?
I thought you were trying to reduce to big n to the power of 3 to n square.
Oh, so this is n squared for now because we just have to look for
Okay,
some I with I less than j such that we maximize this, right?
right.
And so just
Yeah.
like for every j, we look for an I such that and then we look through every I and then we just maximize it. And so my claim is that we can reduce to all of n because what we do here is this function here is written in terms of I, right? But we can rewrite this in terms of j. So sorry, some people are like passing by me, but so how do I do this, right? Let's just say uh let's just say min p sub j, where we say min p sub j is like the I'm trying to like use your language here. It's like the uh it's like piece of like arg min from 0 to uh j, non-inclusive. So it's like that, right? For the arg min, it's like the minimum from 0 to what you have seen so far, right? So we can
Okay.
like rewrite this in terms of j, right?
Right.
So so because we want to minimize the subtraction, we just look for whatever the minimum we have seen so far up to j, right? This is more like a
Mm-hmm.
more formal way of saying it.
Yeah. Yeah.
So this is like saying so what ends up happening is the equation that we get is a piece of j plus one minus min piece of j. So we just loop through every j, and then we don't have to like consider this I anymore because we were able to like rewrite I in terms of j. So as I say for every j, uh, we want to maximize piece of j plus one minus min piece of j, right? So this will be an O of n. So time complexity is going to be O of n, and then space is going to be O of n because we need to know what the minimum. Actually, we don't have to space doesn't have to be O of n, but there's a way to make space to be O of 1, but I'll make it O of n first because the code is a lot better, and then I'll make it into O of 1 space. But yeah, so time and space is going to be O of n and O of n, and you can reduce the space to O of 1. But I'm just being
Yeah,
more quote unquote rigorous here.
yeah. You can do big O of one, and let me
I'll do big O of n
let me
first, and then I'll do O of 1 afterwards. Okay.
yeah. So let me try to read it again. So we want to maximize p j plus one minus the minimum number of p of j when we
Yeah.
search for the first. So basically, that becomes a search problem for the j index that it can give you right for give you the minimum number for this guy.
Yeah, but the thing is, you're taking, but then the thing is, you can actually put this into O of n, or there's like this query here could be O of 1 because you just keep taking the minimum from the beginning up to j, right?
Oh, so you keep okay, yeah. So you keep comparing with the one before.
Yeah, to the minimum we've seen so far, right? So
Okay, yeah. I okay. This is not the way I think of it, but yeah. If that makes sense to you, and you can feel free to call it up.
okay, so I'll just
Yeah.
comment this out real quick. Um,
And this is not
so
an easy question. If and once again,
this is
and for
not easy.
me
Yeah,
at least,
so this
yeah,
is
it's
not
not for
easy.
me.
So let's just say def max. I'm just looking up here. um,
Well, you're a smart guy. That's why I had to pick a harder one for you. Otherwise, you don't get annotate.
say p is equal to this. I'm just gonna build a prefix sum now, right?
Right.
Um, so now I'm gonna build out the minimum we've seen so far. Okay. I'll just say math.int. Let's say for x and p, minimum p dot append. So it's gonna be this with the x, and so now it looks like it's gonna be like inf here. Let's just say p is like let's just try this example here. So p is gonna look like 0, -2, -1, -4, and then minimum p's will look like inf 0, -2, -2. So it's always going to be like have like this little offset. So we're good. So if you look here, the minimum we've seen so far at this j is going to be this -2, right? Just here. So that's what I'm
Slow
doing.
down, slow. Let me catch up. So I'm still reading the first few lines actually. So p is equal to the 0, okay, and then for all the numbers in the number, for all the x in numbers, and then
Yeah,
you append the last number, which is the access to the negative one index of the p,
yeah,
and then plus the x. Okay, so that is doing okay. This is doing a running. It's doing a running sum, right?
yeah,
Yeah. So basically, p is a running sum, and then you have the mean of p, and it initializes is a bigger number, infinite number, and
yeah,
then for all the running sum in p, and then
yep,
basically you're doing a mean p dot append
yep.
the mean of the last one, okay, and then the current number, okay. So this is basically you doing the running minimum.
Yeah, and then it's offset by 1 because I just put infinity in the beginning, right?
Right. Okay,
Right.
yeah.
And then now we set this up. Now we just have to find the
Yeah,
now we
yeah.
just
Can you put back in? Can you put back in the number that you just erased? Yeah. I want to trace back. Yeah. Good. Let's leave it like this.
okay.
I
I'll
try,
just
try to
put it on
follow
top.
for
Yeah,
catch up with you, so I
yeah.
understand your thought.
I'll just put it up here. Okay. And then now we have the equation for this, right? So we just get the minimum. We find the maximum of all of it, right? So
Right.
return the maximum of let's say p sum minus how should I name this? Actually, I'll just use the variable here. I'll just use this equation here just to like make it better. So let's just say query is go to lambda j return piece of j. Well, it's a return. No, there's no return in this one. So I'm just gonna have this. So piece of j minus min piece of j, right? So it's just the equation, right? So we just return the
Mm-hmm.
maximum of array of I for every I, right? Right. So
Okay, you have the query. Okay, you are checking the difference between the P of J and the minimum of P of J. And okay, and then doing that query for all the I
yeah, but actually
in
this actually doesn't make sense because we did piece of j plus one, and so we just have to do a len plus one here. Just it's gonna ignore the very last number. Let's say like we have three numbers, right? Say 1, 2, 3. Then the p is going to be 0, 1, 3, and 6. And so like it's len nums. We want to include the 6 here to include this entire thing here.
right.
And so let's say len p is going to I'll make it like a inf whatever I'll just call it I. It's going to be 0, 0, 0, right? And it's going to be a 0. And so we want to do plus 1 here because we want to include this as well. 6 minus 0, right?
Yeah, I'm trying to. So you have a min of P, and then you have query. So the query is the difference between it's the difference between the P of J
Minus min
and
pj.
minus the min PJ,
Oh.
which is so.
According to
And
this
then you take a
formula here, right? Yeah.
right.
Yeah.
So okay, so at the end you getting the difference. The biggest difference will be 6 minus 0.
Yeah. You just maximize the overall of it, right? And so the thing is, we don't have to include this very beginning part 0 minus infinity. So to be more precise, we just do from 1 through that, right? From 1 through here.
Yeah, I'm not fussed about that indexing thing.
Yeah, but that doesn't matter. Yeah.
Yeah. That it doesn't. Okay, well, this is let's walk through another example. Walk through this one with me. And then you can test your code.
Yeah.
This is not the official solution. Run this one.
Okay. So let me just I'm just gonna print out the prefix sum here, okay? Because I don't want to go through the so I'm just gonna say so I'm just gonna print this out, okay? I'm gonna print out the p, okay?
Right.
Uh, whatever. It's more like a cheating thing.
And by the way, this question was asked by LinkedIn, Amazon, and Apple, and Google,
Okay.
Facebook, all these big companies for many times in the past 6 months, like 30, like 20 something times
Yeah.
on LeetCode. So this
So
is
p.
very popular actually.
And then now we say let's say p is equal to let's see, just gonna offset like this. Should be I is equal to like infinity, so it should be 0, -2, -2 still dominates. It'll be -4, -4, -4, -4, or and this will be -4. It will look like this, right? So now what we're gonna do is we go from here to here. I specify from here. I specify this for
Right.
loop here, and then we just take the
Right.
maximum of or all these differences, right?
Right.
And that's the query, right?
Yeah.
Which is yeah.
So okay, so basically you check in 0 minus 0,
Yeah.
-2 minus -2, right?
Yeah.
And then -1 minus -2, which is 1, and then -4 minus -4, which is 0, and then 0 minus -4, which is 4. And that is your, oh no, not yet. So -1 minus -4, and then 1 minus -4, 2
Actually,
minus
this
-4.
is a low offset. So now I have to make it look like Let me see how I'm doing the queries. So I'm saying I'm doing it's off by 1, right? So this will be compared to this. This will be compared to this. This will be
Yep.
compared to that. Yeah. So
Yeah.
so to get the very first subarray, to get this subarray here, you're just gonna be -2 minus 0, right? To get this.
Yeah. Yeah. Yeah.
Yeah.
Yeah. And then the biggest number is over here, right? Negative positive 4, but positive 2 minus negative 4, right?
Yeah, yeah. That'll be 6.
Yeah, that's 6, and that's 8. Basically, it is from, actually when you look back to the original array, is from here, right? Is that here?
Yeah.
Um,
That's 3 and
yeah,
then
yeah,
6. Yeah. So
yeah. Oh, okay, yeah. Interesting. Okay.
yeah, we can
This
try
is
running it. Yeah.
yeah, yeah. If you want, yeah, yeah. Go ahead, go for it.
So we have all the examples here, right? So let's just say um I don't know if I don't know if I have to worry about like empty stuff, but I'm just gonna ignore that for now. Like if it's empty, I guess you return a 0. I'm not sure. So I guess if it's
And
empty here,
yeah,
go
also I
ahead.
want to add a couple more test cases as well. So let's try empty. Let's try 0. Let's also try -1 and
Yeah,
-2, and also try the other way around, -2, and I think this should be the same,
yeah,
but
because
just
-1, right?
yeah,
Yeah.
yeah. Let's try them.
So I'll just put whatever blend nums is if it's empty, right? Just
Hmm.
return a 0, I guess. Um, and then now we just say
Yeah,
uh um oh, math is not oh, this is Python 2 point. Whatever, I'll just do it this way then.
yes, 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 exactly. Good,
So we get 6 for the first one, and then we get 1 for the second
good,
one. 23,
perfect.
0, 0, -1, -1.
23. Let me see. 23. 4, 5, 4, 9. 9 minus 1, 8. 8 plus 7, 15. Okay, good. And 0, 0. Okay, -1. Okay,
So
good.
this is using memory. So you could do this without
Yeah,
memory because you just
this
keep
is,
track of this as you go.
yeah. I want you to do it in big old one space.
Okay. Let's. So I'm just gonna convert this to big old one space.
Oh, but by the way, before you erase it,
I'm not gonna
so
erase it. Yeah.
yeah, so you're doing like a big old N and big old N and then big old
Big O
like
N
a big
space.
old
Big O
three.
N space, right?
I mean, no, I'm talking about time. This is big old 3N, right? This for time complexity,
Yeah, but then it's big
right?
O 3 and it's still N, right? So it
Yeah,
doesn't. Yeah,
yeah, yeah.
you can like hand wave the you can hand wave that, right? I'm just pre-computing, caching a lot of these bunch of these queries, and then so yeah.
yeah, yeah. I know you're a smart guy, so I'm gonna tell you that a better solution is a big O of 1 times N for time complexity, and space
Yeah,
is big O 1.
yeah, you can reduce this to big O of 1 because you just keep tracking. You just track of this, right? So let's just say fix sum equal to 0, and then let's just say min p is equal to load in, right?
Yeah, yeah. Okay.
And then now we
Yeah,
say
yeah, yeah.
for x and nums p sum plus equal to x, and then min p, and then now we say what is our answer? We want the answer is equal to, let's just say, negative infinity. So and then now we say let me think. We did that. Okay, so we don't want to keep track of this yet. So we say answer is, because we want this to always be off by 1, or we want like
Right.
the off by 1 from the previous minimum we've seen so far. So it's gonna be sum of answer p sum minus min, or I guess min so far, or whatever you want to call it, and then we say min p equal to right. Um, then now we can like kind of get rid of all this. Yeah, I think that's it. Yeah, so let me just run code again.
Yeah, yeah. Try it.
Wait, hold on. Wait, did I mess up somewhere? Oops.
Well, you
I
mess
got.
up. Hang on, but you are close. Yeah, you are
Yeah,
close
yeah.
to the
Let
best
me.
solution. But yeah,
Yeah,
well, that's
let me
really
think
good.
about. Let me think about this. Real quick. Okay.
Yeah, yeah, no worries.
So. Um. So we add that. Let me just run through this code real quick. So this should be a 1. It should be negative infinity. So I just kind of rushed real quick. So let's just see. Okay, let's just walk through this.
Yeah,
So
yeah, I'm gonna
so
shut up,
psum
and
it's a
then
1.
I think you're close to crack it. You can do this.
Okay. Okay, I can just kind of like hard code this if else right. It's kind of dirty, but so basically what I'm saying is if min p is infinity, uh if it's not infinity, then we subtract it. Otherwise this gonna be the prefix sum. So if I run through this here, p sum should be 1, answer should be minimum of answer, and then should be 1 minus it should be 1 minus min p, which is going to be it's just be 1, right? And the min p is going to be minimum of that, and it's going to be 1. So okay, that's good. And if you look at the 0 here, um if you look here, so it should be p sum is 0, and the answer is going to maximum of answer, which is negative infinity, or it's going to be 0, right? Because it's already infinity. Otherwise, so what I can do is to make it cleaner, I guess I'll just use indexing because this looks kind of dirty. So answers to be this. I guess the max sub. I guess what should I call it? Subarray. That's subarray. So p sum if I greater than if I is equal to 0. Otherwise min p, right? And then we just do that, and then that's it. Do you follow?
Yeah, yeah.
Yeah, because like we said before, we will always want this to be off by like 1 before. So yeah, so I just run code. Wait, what happened here? Oh, this part. Um, 6, 1, 18.
Not
Wait,
yet, not yet.
wait,
Yeah, not
wait.
yet. This one doesn't
Yeah,
follow.
hold on. Let me
Why equals 18 though? 5 plus 4.
let me think. Oh my gosh, this should be like. Okay. Let's see. Norms plus 1. So okay, what's this? Where's the subarray? So it's just adding this entire thing, right? It's 9, 8, 15, 23. Okay. So it's gonna be 5, 4, 18. So at the end, it should be 23. Oh, it should be wait, hold on. 9, 8, 15, 23, right? Yeah. So
Yeah,
it should have added this entire thing. I see what's going on. Minimum p could be 0. It's not this is actually wrong here. because the way how I set up min p before was min p because we don't have to we don't have to take anything, right? We just sum this entire thing up. So what I had before was, remember, everything was off by 1. So min p was
Mm-hmm.
like I comma 0, right?
Right.
Yeah. So instead of here, I actually put I comma float infinity. So because the thing is, if it's 0, that means you're not subtracting with anything. So you're just taking the entire thing, right? Up to that point. And
Yes.
that's why you need to like hard code in. So let's see. So what you can do is you actually don't need this anymore because you just min p is always going to be 0, right? So
Yeah, exactly.
yeah. Oh, sorry. Oh, that's
No,
embarrassing.
no, no, no. You're doing great. Yeah, no, no, you're doing great.
Yeah. So it should fix everything. Yeah. So okay, cool.
Perfect.
Yeah, that's why I like doing this approach better because it's more like precise. Than doing these like quote unquote all of one solutions, but because like the formula is easier to map, right? Because here you just keep tracking of the running a portion of it, but
You must be honest with me. You have never done this before.
no, I've done this problem before, but
Oh, you've done this before.
I don't want to use the Cadence algorithm because it's like you kind of know it, or if you don't, then it's like that. But so I just want to like showcase different ways of doing it. But like you can ask me harder problems. But then like so I'm trying to solve this problem from first principles, right? So instead of like using some like some kind of
Trick.
like known greedy or algorithm, right? So I'm just trying to like
Yeah, okay.
showcase that, yeah. Because you can
That's
actually
very
use
cool.
solve because if you do it this way here, you can solve this problem using a heap because you have to know the minimum thing you've seen so far.
So, how long it take you on the first try on this for this question?
No, I got to here. So I got to here. This took like maybe like a couple minutes. But by a couple minutes, I mean like I already knew how. Whenever I see this, I can pattern match to here real quick because I've done it
Oh,
before.
okay.
And
I
then
mean, I mean,
now I was figuring out
I,
about like
I,
doing this, right. So go ahead.
yeah, yeah, you said you have done this before. I mean, at the very first time you saw this question, how long it took you?
I actually can't give you a right answer because like my skill level when I first did this is like way different from my skill level now. It's like asking like a first time swimmer, like how quickly can you do like a 50 meter from like a beginner swimmer, right? And then now
Right.
you swim for a couple years, and now you're asking like how quickly can you do 50 meters? So it's not a is I don't think yeah, I don't think that's a good question because it's probably like
I'm just,
different because obviously
I,
I sucked when I did this lead coding too, so I know where my quote unquote humble beginnings are because it took me a while to get to where I am right now. So
yeah, fair enough. I mean, it took me like an hour and a half to figure it out.
I think that's fine as long as you learn your lesson, right?
Yeah, exactly. I not last week. You.
Like
I
yeah,
think
go
that
ahead.
it was well. Yeah, it was well said. You said don't try to memorize it. Try to understand the approach.
Because like this is because like you're like if you do it this if you frame it this way, like you said, this isn't part of the official solution, like you said. The official solution part uses the quote unquote the cadence algorithm, whatever they call it, right? And so like if you frame it this way, then then you can like sort of like solve from first principles, right?
Hmm.
Because
Okay.
I didn't do anything fancy here. I just tried to like this part maybe a little bit fancy if you haven't done it before, but it's like a common thing to do to like to get a separate sum. You subtract their the prefix so that you can cut off like the overlapping parts and you keep the non-overlapping parts.
Yeah,
So you
yeah,
got yeah, so you got like
yeah,
this and then
exactly. Yeah,
yeah, so
exactly. When you, yeah, 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 and then you cut off the front, right?
yeah, that's what I'm doing. So this
Yeah.
comes from experience. Um, this comes from experience, like because what you're doing is you're just keeping tracking of the running minimum, and so you can do stuff like this, or you can just keep track like this as you go. But I think once you get to here, you should be able to reach here. But trying to like express I in terms of j, so that you don't have to run another for loop, may take some a bit to think about. But or you can say like it can be like this min. Instead of doing this, you can formulate it as a min piece of 0 to j, right? Right. And if you like formulate like this is like it's kind of like this, and then so and then if you see if you see this, you just keep taking you just keep going from the 0 to, you just keep taking slices of it as you go. So, but
Yeah, and yeah. This is how I would solve it as well. I mean, after I understand the solution, but there's another approach using the divide and conquer.
divide and
Um,
conquer.
yeah, at this point I still don't fully understand the solution. But if you are interested, you can look it up. Um,
Oh,
divide and conquer
I
can
think I get it, right? Wait, divide and conquer. Let me think about
yeah
this real
you
quick.
can.
So let's just try like understand it from first principles again. So we have this. Let's say we have like all of this here. So how do we do divide and conquer here?
And divide and conquer is not. I mean, it's not faster than this approach though.
Yeah,
It's
yeah,
not faster.
but
It's
it still
take.
gets the job done, right? So
You can get the job done. Yeah.
yeah. So we're given this. We're given this and this. Okay. So this is like for sure we're given. We can extract these two pointers from this here, and then like we can get any arbitrary positions in between these two pointers, right? I mean that's like a fact, right? I mean those are I guess like from like that's what we can possibly do. And so I'm thinking so what happens if you like divide it by half? So I actually don't know divide and conquer solutions. I'm just trying to figure out as we go now. Because
Yeah.
and so we can like recursively go here and we can recursively go here. But I'm trying to figure out like how does that give us the best array, right? Because otherwise, or what if you know what if it goes through this? What if the subarray may go through this position here as well? Uh, so so that's another thing I'm trying to think about. Because you're trying to get n log n, right? Or maybe a little bit faster
Yeah.
than n log n.
Yeah. It's actually slower than your approach.
Yeah. Because I'm trying to think about the combining part. Because like if combining goes to the center, then it will do this. But I'm trying to like figure out like how do we formulate it so that we can like we can get that right. So let me think. Uh, so the base case is if it's empty, we can't do anything. Otherwise, let's say like dividing left is goes to this and dividing right goes to that, but it doesn't give us this here. Do you have any hints?
Well, I don't. I mean, myself don't even fully understand the divide and conquer. I don't know how to give you a hint. But it's on the solution. But you have premium, right? You can look at the solution if you want.
There's a solution for divide and conquer.
Yeah, I can show it to you if you haven't seen it.
Um, hold on, don't give me the
But
solution yet. Like because like the only thing I'm trying to figure out is how do we I'm trying to like use the middle, right? Because this middle potentially could be a
Yep.
part of
Yeah, you're right.
like a
You're right.
thing, right?
You need the midpoint. Yeah, you're right.
Yeah. So uh so how mm, so one way to do this is if we divide here, we have to make sure that it ends like here, but we have it ends some kind of like suffix here. And if you like divide here, I have to like end some kind of something here, but I don't know, man. That looks kind of weird, but
Yeah,
uh
but you're on the right track. You basically you keep dividing the array,
yeah
narrow it down until a point where you find a. I doubt the interviewer will ask you something like this. Use the divide and conquer. I doubt it.
yeah
Um,
because
but if you
because the thing is if you want to get this part like so let's say we look at the middle, right? If you want to know what is the best prefix sum from here to here, right? Then we just it looks like we just keep expanding, but that's like a theory I have. And then maybe the same could be said for here too, because like you just want to maximize. Oh, is this a maximum? Is this a maximum? Is this a maximum? Whatever, right? So if you can find that, then you can somehow include the middle, right? Just by like adding all that, and same could be said for here too. But like and then maybe you want to like recurse left and right, but that's like I'm not sure if this is entirely correct, but that's like the intuition I have. If you want to like include the middle, instead of finding the best optimal point from divide and conquer from expanding, or from like let's say like left equals like divide and conquer left and right equals divide and conquer right, and let's say that might give you the point for which is optimal. What you can do is just if you just want to solve the problem, get the job done, then you can just expand the left as much as you can until you get the maximum, the prefix or best sum, right? To here is this the best, is the best, is the best, is the best, is the best, whatever. You can like brute force to here, and then let's say like
yeah,
this is the best
you're
one,
close
and
actually.
yeah,
Yeah, you are close.
and
Basically,
then
you
they use that
basically
for the
from the
right part as well, right? And then and so if you do that for right part as well,
yeah
you get like
yeah
this here, and then you make it even
yeah
in the front part you get like this here, right? So in order to like quote unquote join it, you just add the middle. But
exactly yeah. You basically push from the middle
yeah,
to the left and then to the right, and then one at a time, and then find the max, and then at the end you combine the two max.
yeah, and then in order to like ensure that you do this for every point, if you recursively divide every point, it's gonna hit every point, right? Because if you recursively
Exactly.
do it for here
Yeah.
and if recursively do it for here, and then you just keep defining the maximum for all of that. But
Yep.
yeah, that's not like a non-intuitive approach.
No. Yeah. This kind of like a weird way to apply divide and conquer. I mean, divide and conquer to me, it's like merge sort. Like it's like
Yeah,
kind
that's
of
how
a
it's introduced. Yeah, the concept is
yep.
introduced through that way. In the merging part, dividing you just keep cutting by half and until it's like one pieces, whatever.
Yeah. So it's kind of using that idea here, but
Yeah,
I don't think this is the best interview question to ask the interviewee. I don't think
no,
so. But I think if you can get to this stage that you know one 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 step at a time and then you go to the left and go to the right, I think this is really good answer already.
yeah.
Um, okay, I think you have done a good job on this, and yeah,
Do you have any like harder questions? Because like I have like different ranges of questions I can ask you, and I don't want to like give you like like you got what I'm talking about, right? Because like for like binary search,
mm,
I may have like range of different binary search level questions, and so like I'm just so like
just try me a medium, it's fine.
yeah, because like
But don't tell me is that binary search or is other. Let me try to.
I have different ranges of questions for different topics.
Right.
That's what I'm saying. So I just want to know like where you think you're sitting on in the spectrum of
I
your
think I'm more like a medium guy. Okay.
Okay.
Yeah. Or medium
'Cause
to easy. I mean,
yeah.
yeah, the hard question probably sometimes take a bit time for me to figure out. I only finished like a bit more than 100 lead code. I'm
Don't think
pretty
about
new
numbers. Don't
actually.
think about numbers. It's like
Yeah. Last time you said that again.
just think
Yeah, I
about like
remember
how
that.
comfortable you are with those topics. That's how I would gauge them.
Right.
Okay. Because I'm like different levels of graph questions. I can maybe ask you. That's why I wasn't like so sure. So when were you working on this particular problem?
A month ago.
Yeah, I should just save it for now. Okay. Because like, do you want to like talk about like other DP stuff or whatever?
Yeah, doesn't really matter. Just I tried not to know what kind of
Okay.
pattern I'm given,
No,
so I
you
just try me
asking me. You
anything.
don't know what you want to ask me, right?
Oh, okay.
Like let's just do one more, and then I'll show you my thought process on it, and then I can quickly go to you. I'll ask you like medium questions, like you said.
Oh, so you want me to ask you one more?
Yeah, yeah. For here, I kind of just jump straight to here, but if I'm in the mood of like I need but I try and like be as thorough as possible to to show my thought process here. But yeah,
I don't have anything to ask anything else to ask you today though. I only prepare for one question for you.
you only prepare for one. You can look at your history and then see like which one kind of and I try to like use my thought process on it because I hate memorizing solutions too because what I try to do is given a question you try to like reduce the problem to like its most abstract form and then try to like solve from there like how I did for our previous DP problem, the one that Pramp asked us about the minimum deletion distance. Like I try to break it down to a graph, right? And I solved it from a graph point of view as well. So I try to look
Right.
for these general structures within the problem that you can reduce the problem down to.
Let me think. I have to think about what question to ask you though.
Yeah, I know today I
Uh,
kind of put you on the spot. Hey, let's do it at 9. So I understand that you didn't prepare for tonight because you had the thing going on.
yeah, maybe I can ask you one more next time then.
Okay.
Yeah. If you want like one more next time, I can give you one more because I
Okay.
have to understand the question first before I can ask you.
Yeah. So yeah, that's why I was asking. Like, have you done any questions recently where you know, I guess this
Yeah, I
is a
done
recent
some.
one too.
Yeah, the last time I see it was with you.
Okay. Got it. Yeah, understand.
Yeah.
Um, Damn. All right. So medium, huh? Um. Okay. Okay. So can you show me like which topics you're comfortable with? It should be like almost all
Mm,
of them, right? Because
yeah,
what I may consider a medium might be hard. So I'm just trying to like poke around here and there.
mm, I don't know. I don't have any particular area that I'm good at, and I don't want to get practice on the area that
Yeah.
I'm good
Yeah.
at. So yeah, just anyone that you can find.
Okay. So I'll do a mixed topic then. Yeah. Okay. So let's say so how do you want to do this? Do I read the question or do you
Yeah,
want
you
to
can show me. Yeah, you can show me on as wording on like you can paste the
okay.
question on the screen, and then I can
So
see it.
I'm gonna clear this. Okay.
Okay, sure.
Yeah. So I'm gonna hit reset and then so let's say we're given this. So I guess I'll just paste it here. So and then so you use the grid looks like 0 to 1 comma 3, and then you want to know the minimum time it takes to reach to here from like from the left corner to the right to the bottom right corner.
Okay, let me read through the questions. You're given n by n integer matrix grid where each represent the elevation at that point. The rain starts to fall at time t. The depth of the water everywhere to is you can swim from a square to another 4 directionally adjacent square if and only if the elevation of both squares individually are at most t. You can swim infinity distance in 0 time. Of course, you must stay within the boundary of the grid during your swim. The least amount of time until you can reach the bottom right. If you start at the top left corner, okay. So you can because of a higher elevation. What does that mean? That's swimming, like what
So it
elevation?
means so if it's like you can think of these as like a mountains, right? If you can go to here, you can go from 0 to 2 because 2 is filled up of height 2, right? Time is filled up of height 2, so you can swim from here to here, right? But you cannot swim from here to here when time equals to 2 because there's that one little it's like a little mountain there you can't swim over, right? But it's like think of it as like an ocean full of like a like at the bottom of the ocean there's like a bunch of mountains, and then you can only swim, you can go from like one point to the other if it's filled with water, right? So think of these as elevations.
Okay.
And so in order to go
So
from here to 3, it has to the elevation has to be at least 3, right? For you to go.
essentially, what it's saying is okay. Let me read it again. Elevation that one range started for time t. Higher.
So let's say you want to go from 0 to 2, right? From left to right. Imagine like this is like a this 2 has like elevation of 2, right? Um, so if you're here, I guess if you're here, there's like no point you can't let's say like initially there's no rain, right? So you cannot go over this, right? And you can only go over this until this part is filled with water, right? So that you can like swim across, right? And every second like this thing slowly gets like filled up with water, right? Right. Do you have any questions?
Yeah, I'm still thinking.
Okay.
So at time 0, the amount of rain is 0, right?
Yeah.
And then at time 1, the amount of rain is 1.
Yeah.
And if I am this point, which is elevation of 2, that means
You have to look for the minimum time, right? It doesn't mean that
okay. So at
yeah,
time 1, I can only go from 0 to 1,
yeah. You cannot go from
and then
0 to 2, right? Yeah. That makes sense.
and then I cannot go. I cannot go from 0 to 2 until time of 2,
Right.
because the time the water level keep going up until the time of 2.
Right.
Okay. Now I understand.
Right. Okay,
But
cool.
okay, so but but so let's say uh if the question was looking like this, um so let's say if this one is 2,
Okay.
and I can reach here at time of 1, right?
No. Because
Because it takes no time.
you have to wait until the rain fills up the 3, right? Because you still if you're here, you still need to wait for the water to fill up all the way to 3, right? So you can go from 2 to 3.
Oh, okay, yeah,
Yeah.
that makes sense. Okay, I understand. Yeah, okay, so this one takes 3 unit of time to fill up. This one takes 2 unit of time to fill up, and this one
Yeah.
only take 1 time to fill up. And for this example, it takes no time to fill up because it's already at the top.
Yeah.
Okay, like a fish tank.
Yeah, I see what you're talking about. Like, if you like normalize it, then subtract everything off by 2, then it might be like 1 second or whatever, or 1 time or whatever. But no, it's not like that.
Okay, wow, this is. Let me think about how to do it. So, and what we need, the least amount of time until we can reach the bottom right.
Yeah.
If we can, so okay, I understand now.
Like you can
Well,
like go ahead.
yeah, I
So
think
you
my initial.
go
Go
ahead.
ahead.
Yeah. Okay, I want to hear your thoughts first.
Yeah, my initial thought would be uh the maximum number among all the numbers.
But that might
Okay,
not be the least time, right? That will guarantee a time, but that's not the least time, right?
yeah, yeah, yeah. You're right. You're right. So can you do you have any, some more examples?
Yeah. So uh, let's see here. Um, um, this is kind of bad. um, this here will be 16 because let's see. Let me see the path. So the path is like this. Go down to 5, and you go to 16, and then you go all the way to the left. So I'll just draw like this. And then you go down. And then from 11, you go to 10, and you go all the way to 6. Right?
Yeah. So
So,
okay, I got it now. So essentially, it's the biggest number that among the number on the path that you traverse,
okay.
right? So in
That
this
could be one way of doing it, but yeah.
yeah, essentially in this example, well, yeah, you go from 0 to 4, and then 5, okay, and then go down 16, and then 16, and then don't go down because you have to wait until 20, and then go to left, and then go down. Okay, this is okay. This is like a Z. Okay. Uh, Um, the number is like a barrier, right? You have to wait until a point in time that you can hit it.
Yeah.
I'm most thinking about I use a min heap.
Okay.
For each pawn, right? You look at so for example, when I was in the first pawn, I look
Yeah.
at the 4 surrounding pawns. So look
Okay.
at the minimum number. And for the first guy, so definitely this is a DFS problem, a graph. So for example, in the first point, I'm looking at 4 directions. I mean, on the left, it's going to be boundary. On the up, it's going to be a boundary. On the left, it's going to be a
Yeah.
1. The bottom is a 24. So I don't go 24, so I go left. I
Why
go,
don't you
go to the
go?
right.
Well, what if you have to go 24? How would you deal with this, right? So yeah.
Sorry, if I have to go to 24?
You may, right? Depending on like what if this was like 25, right? You may have to go 24, right? So
Oh,
it's
okay.
gonna depend on the
Yeah,
problem, right?
so,
So yeah,
yeah, okay, I got it now. So basically what you're saying is depend on
on the graph, right?
yeah, basically depend on the number at the end. Is that what you said?
Yeah. So I'm just showing you a counterexample of why where you might have to include this 24, right? Because like
Yeah,
this, yeah,
okay, yeah, I understand what you mean. So essentially what you're saying, if the number at the end that was really big, so any number any number between the first number and the final number, will be okay, right?
okay.
Um, however, in this case, it's the last number. So okay, that was a good point. So
Because you're trying to avoid 24, but I'm just yeah.
yeah, let's have a two example. So if the example looks like this, so I will go the first number and then go down and then go down and then go down, right?
Yeah.
And then go down and then go to the right and
Yeah.
then hit the last one. And so and also so it depends on the number at the end as well. So
Because
all
the
the
number at
number,
the
I
end
mean,
is the maximum. Is the maximum in the path, like you mentioned, right?
yeah, exactly. It's the maximum of the path that I have to go.
Yep.
Uh, okay, so I change it a bit on the strategy. So for each number, I look at 4 directions.
Okay.
So if that number is is smaller than if okay, there's 2 scenarios, right? So if the neighboring number
Okay.
neighboring number is bigger than the last guy, or if the neighboring number is smaller than the last guy. Okay, so there are 2 scenarios that we can talk about in here. So if that is smaller than, I mean, if that's the neighboring number is bigger than last guy, probably I can choose the different path, choose a different another neighbor.
Okay.
And if this is smaller than the last guy, so I'm okay with that.
Okay. But
Um,
does this hold? Okay. So keep going. I want to see where you
but
go
you
with this
talk,
idea. Yeah.
yeah, and this is not necessarily a shortest path, right? It's a shortest time.
Shortest
Uh,
time. Yeah.
yeah, it's not necessarily shortest path. If this question was a shortest path problem, I probably use a BFS.
Okay.
Um, yeah, and this is not. So, uh, oh, this is a tough one.
Yeah. This question has like 5 different approaches you can take. That's why I asked you. But
Oh, gee.
that's why like I can like kind of gauge where you're at in terms of like I don't say maturity, but I just want to see how you think about this
Right.
problem.
Okay.
Yeah.
Okay. Cool. Um, Let me think. Yeah. So
So I know the intuition what you're trying to mention here. Like I know what this I know what you're trying to mention here, but I'm not gonna say it. There's an idea for this, and that's one approach of doing it. But like once I tell you, you'll be like, oh, okay. um,
yeah, I almost need like a running max of time,
that's okay, okay. But
and
yep.
yeah, go ahead. Go ahead.
The keep going, keep going.
Yeah, I think if let's say if I this is a DFS approach, so I need something like a stack and
Okay,
stack dot append something like the row index and column index and then the max time at that point.
okay. But how do you know? But this is a DFS, right? It's not gonna like the thing is if you go if you take the minimum of the max time, it's gonna it's gonna explore everything, right? So how do you want to prevent from exploring everything? It's,
It's gonna explore everything.
like you don't wanna like explore this to this to this to this to this, right? 'Cause that's unnecessary, right? So if you take the max or min or whatever, then if you want to take the maximum of that path, it's gonna be the maximum of this entire thing, right? So I know I know the idea of what you're trying to do because you mentioned it
Well,
briefly before.
well, the max time is the maximum time that for a particular path that is going through
Yeah,
that
yeah.
point, right?
But the depth first search, if you look at it in terms of a search tree, it's going to explore everything, right? But you don't want to explore everything. We only want to like hit certain nodes, right?
Oh, yeah. So if that's the case, I would compare. Um, yeah, I compare again the neighbor that we talked about, right? The only
Yep.
the neighbor is smaller than the last guy.
So let's just kind of go back a little bit earlier, okay?
Okay.
You brought up min heap. That is a very good idea. Can we go with that solution? Can you run with the idea of using a min heap? Because every time you pop off a node from a min heap, what does it pop off, right? Let's say from
Yeah.
zero, you append 24, but this 24 never gets popped off, right? It's still in the heap, but it never gets popped off, right? Because
Oh,
they're
okay. Yeah. The next one is gonna be 1 and 2 and 3 and 4 and 5,
yeah.
and then 5 is gonna be 6. 6 is gonna be the last one though, and then
You mean
7,
no, the
8.
from five you can't jump to six. From five you add 16 and 21, right? Or something like that, right? But then the 21 will never get popped off because the 16 gets popped off first, right?
Right. Right. Perfect. Yes. Yes. I
So
got it.
this is called Dijkstra's algorithm. What we're doing is Dijkstra's. You append whatever into the node, and some nodes that doesn't get popped off. It means that if you reach the target node, the nodes that didn't get popped out aren't isn't part of the path. That's what Dijkstra's is.
Perfect. Yeah.
Dijkstra's is
Yeah.
like
Yeah. Yeah. That's
DFS, but you pop off the nodes based on their the weight.
yeah. The okay. Okay. The cost. Okay. Good. I get it. I'm gonna code it up then if you're okay.
Okay.
So
Okay.
let's yeah let's do another dry run. So
Okay.
basically, I'm in the beginning, right? And
Yeah.
then look at surrounding neighbors, right? The
Right.
1 and 24, and then append it to the queue or oh, no no I can yeah the heap.
It could be a queue, whatever, right? Doesn't matter. Yeah.
Yeah, it's going to can be a priority queue, and then when I and then I pop it off the highest priority, which
Yep.
is the one in here, and then I collect the adjacent neighbors again. So it's 2 and 23,
Yep.
and then the 2 will pop off, and then it's gonna be the next one. It's gonna be 22 and
Yeah,
3,
you don't have
right?
to do it
And
for everything. Yeah, you don't have to run the example for everything. Yeah, I get the idea. Yeah, but these are still
perfect.
in the heap. These are still in the heap. So that's what I have to like
Yeah,
articulate. Yeah.
yeah. Thank you for the push, and that yeah help me a lot. And let's call it up
Okay.
and then call it a day.
All right. Because there's a different idea I was trying to I want to see if you see this different idea as well. Can I just briefly mention it?
Yeah, yeah, for sure. Yeah, for sure.
What you can do is you can binary search for the answer. Because let's say from a physical intuition, let's say you're in a swimming pool,
Right,
right? If you wait for infinite number
right,
of time, that means that the swimming pool is already filled up. So you can like traverse from the starting point to the end, right? And so like if you're looking at it from numerically, let's say like this is like infinity, right? Then it's always gonna be like true or around here, right? So this part will be like true, right? Because if you wait infinite number of times, it's gonna be true, right? So
right.
this will be true until a certain point, and then from here it's all false, right? So you want to find the first true, so you can binary search for the answer. So let's say like so like your search space might be from like 0 to whatever the maximum element, and then let's say like, oh, if it's like true here, that means everything to the right is also going to be true, so we go left, right? Unless if it's false here, we know from everything to the left is also false, and so we just keep doing this until we find the first true. So you keep
Hang on,
calling, yeah.
hang on, Shan. So, but how do you formulate the thing become true or false?
If it's possible to swim to the neighbor using that time. So search space here will be like from like 0 to like the maximum of the matrix, right?
Right. Yeah.
And so let's say like we have this and one reach here. But let's say like, oh, we're binary searching with 2, right? This will be a false. Let's say like I'll just make it smaller. So let's say it's like 2, like a 4. And so if you do 3, this will be a false because there's no path from 0 to 2, right? But if you do 4, then there's a path from here to here, right?
Yeah.
Because we look at each adjacent neighbors, and let's say if the neighboring value is a less or equal to the, I guess, the binary searching the mid value, then we know we can jump that, right?
Okay. Yeah. Kind of
So
get
so
it. Yeah.
yeah. So it's like a binary search where the query function in the middle, which is usually O of 1, it's gonna be the O of n times n, or O of like a BFS or DFS or whatever, right? So 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 the time complexity will be like log of the maximum of this times then the more work it takes in the middle to check to see if it's reachable, and that's like all of the n times n, right? So I just wanted to
Oh.
yeah, all of
Yeah. Yeah.
the BFS or function, right?
Yeah. 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 I wrote it, but I prefer use the heap
No,
approach.
no,
Like
I'm just saying
the
you can use the heap way, but I just wanted to see like if you ever came across this kind of idea before when you were solving problems. Because if you did had this sort of intuition, like this physical intuition, I was thinking maybe you might have seen this solution as well. But I guess
mm,
so I'll just keep waiting to see where you're going through, and then you gravitate towards the dictionary's way. So I was just waiting, right, to see like how you're approaching this problem.
okay. Okay. Fair enough.
Yeah. So that's why I asked. Let's just code up the dictionaries then.
Yeah. Let's do
Yes.
that.
So sorry. So yes. Yeah. So what do you think about the problem?
I think it's good problem.
Okay.
I like it. I've never seen this before.
Yeah, that's fine.
Is it little medium hard or it's easy?
So it's a little hard, but but
Oh,
but
okay.
but 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 from my standards, I think it's a medium, right?
Yeah,
So
yeah, yeah. Honestly,
because like the reason I think it's quote unquote hard is maybe Dijkstra's maybe a little bit hard from the point of when this problem was maybe published. or maybe you're mixing different ideas of BFS with a binary search or whatever, right? But like those
Yeah,
algorithms on its
and
own, it's not a hard algorithm, right? It's just that you have
eh,
to come to that insight to arrive at the conclusion, which makes it a little bit hard. We're combining a bunch of insights together, right? So, um,
right.
yes, sorry if I apologize if you think I was being an asshole and asked you this hard question. So I because thing
No,
is,
no, no, no.
I'm just trying to like see where you're at, right? So I'm just like this kind of like feels like you get what
Well,
I'm talking
no,
about,
no,
right?
no. You. Yeah, 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 yeah. I enjoyed the thought approach.
Yeah. Yes.
Um.
So we can just I'll
So
just bring up the function here. My approach is all good. I'll just bring up the function here. So it's
yeah.
just
Okay.
cool. Let's just do that, and then you can test the code. And
Okay. Yeah. Yeah. Sounds good. So I have a good. So I have a okay. I have a n row, also n
okay,
column
okay.
equal to the length of the grid. Also the length of the grid.
I have a question. Like,
Zero.
do you need were you aware of Dijkstra's or no? Like because like the way you explained it, it's like you had a sense for it, but
Let me think. Let me think. But how can if I don't have this two numbers, how can I know where is the bottom?
what do you mean? No, I'm saying like were no, I'm asking about these two numbers. I'm asking like were you aware of Dijkstra's algorithm before?
Oh, no, no, never.
Because like
I don't.
yeah, because the way how you explained it was like you had like a feel for it, right? But I was just seeing you if you were gonna utter those two utter Dijkstra's, right?
Maybe yeah. Maybe I came across this algorithm before, but I didn't know the name of it though.
Yeah,
Again, I'm not a CS student.
that's
Even though
okay. I'm not a CS.
yeah. Also, even though I'm taking CS masters, but still it's not my algorithm.
Yeah,
It's on machine learning and stuff.
yeah.
Anyway,
All right, let's just go
but
for this.
but to answer your question, I do not know the name of the
Okay.
algorithm.
Yeah, because like you're like hinting at it all the time. I was just like, okay, I was just waiting. Like yeah,
So I have a heap.
yeah,
It's a queue, and so the first guy is gonna be it's gonna be 0, 0.
okay,
Also okay 0, 0, and also the first guy as well. So maybe something like this, and also the number at the grid
okay,
0, 0. Okay, I have something like this.
yeah,
So yep. While what I'm gonna do is to temp. I have something like okay temp. I'm gonna call it temp cost. It's a cost to me. It's time. It's
okay,
time cost. Temp cost. I just call it cost. And temp temp row and temp column equals to heap dot heap. I think heap q and then heap.
okay.
I'm gonna keep it
Oh,
combined.
it doesn't matter. Yeah, it doesn't matter. Yeah,
Yeah. So okay, good. And also for okay, so and also have the directions. Directions equal to the for adjacent one.
okay.
0. Hey Shan, have you considered Google CodeGem?
No, I don't have time for computer programming. I know what you're talking about though.
Yeah, you seems
Maybe if I have time, I'll get into that. Get into computer programming. But right now, no, it's not my priority.
How many courses are you taking this semester?
Taking 3.
Oh, this is your last semester, right?
No, I was spring after, but it's like last year.
Oh, okay. So this is fourth year.
Yeah,
Okay, cool. How old are you?
21.
Wow, you know what? You're 10 years younger than me, almost 10 years. I'm 30, almost 31.
Yeah,
Well,
you
I
have like
miss
you're like far ahead of me. Knife, it's all right.
not necessary. Don't say that.
But
I waste a lot of
I
time.
don't think about that stuff. But it's fine. Yeah.
Yeah, I waste a lot of time on the actuarial stuff. 7 years.
Okay.
Yeah, and now I get to anyway. I'm stop bullshitting. Go back to this. Shut up. I'm gonna shut up. So I have the temp cost and then the temp row and temp. Okay, so the next one, yeah. So what was it?
What
Yeah.
if you
So
have
I'm
to,
looking.
what if you have to target node, right?
Right. Okay, yeah, that's the terminal, right? So if the
So
temp,
here's a little
yeah.
typo because you put a bracket here. We put like a parentheses here,
Oh,
right?
is it? Let me
Yeah.
see.
So
So yeah.
I think you have to do it this way. So you put a you do this. You just wrap this around here like that, and I think you're
Oh,
good
right.
now.
Yeah. The exit. The
Yeah.
exit condition is looking something like this. So I'm gonna return the result,
Okay.
and also the result is gonna be the max or the max cost.
Yep.
Well, I have to think about how to do the max cost. Okay, maybe you know what? Also have the max cost equal to at the beginning gonna be 0. So I'm gonna keep track of the max cost as well.
Okay.
At each step. Okay, max cost equals the max of the prior max cost and also the current temp cost,
Yeah.
whatever it is.
Okay.
Okay,
That's
so
good.
okay now for D D row and D and then DC. Okay, in directions.
Yep. Right. Yeah, I understand where this is going.
And
You have to
yeah,
explain that
this
line by line. Yeah, I understand where this is going. So you can just like type the code out as fast as possible if you want.
okay. I know you get this. It's just for myself actually. I love
Yeah.
talking.
Oh, okay. Or you like it doing it this way. All right.
I don't know. I
I'll
just
show you how I will write it. Good. People have different
almost this
styles
is
of
the
doing this part.
yeah
Doing this
almost
part.
this is my only. I mean this is my go-to approach.
Yeah.
Whenever I do it.
That's the DXDY.
Um,
Yeah.
yeah. Some of the lead code guy does it, and then I follow that.
Okay.
And then now it's checking the condition. Um, uh, okay, so and R minus 1,
Okay.
0.
Yeah, I know where this is going because I've seen this variation lots of times. So
Yeah,
you're good. You're good. Okay.
Uh, if okay, so and
See. Okay. You don't want to revisit them, right? That's like because you can go from forward to backwards, right?
yeah. Yeah. So I need to have something like a visited or seen.
Yeah.
Seen set. Um,
Uh. So this here, could is actually I'm not saying it's not optimal, but because the thing is you can add this re-add the same you can like repop the same nodes over and over like this way. So I would recommend doing it up here. And every time before you append something, um, I would whenever you push an item, I would also update the scene with it as well. So I
Oh,
would
you mean
set up, so I would set up the
you mean
scene
add it?
here,
Oh, you mean
like
add it over here?
yeah, like this, right? Yeah, I'll do it like this, yeah, and add over here too,
Okay,
because you'll end up pushing the same nodes over and over if you do it from up there.
I have to end up pushing the same node over and over. Why
Yeah.
is that?
Let me think of a tree. So how do I do this? Okay. So let's say you're here, right? And then let's say like there's like a different node that's here. Let's just say cost is like 1, cost is like 2, and then like let's say this is cost is like 999, right? Let's say you can go from 1 to will look like this. Just think of like a triangle, right? And then 1 to 999, 2 to 999, right? So if this is a
Mm-hmm.
root node, we're gonna push this into the queue, and we're gonna push this into the queue, right? As the neighbors of this. Follow so far?
Yeah,
And then
yeah.
when we're not the 2, right? We're gonna push the 999 again. Because this because because
But
the thing
hang
is
on.
9.
I will check in here, right? If and and the next row and next column is not in scene set,
Yeah.
so it won't be
Yeah,
pushed to that.
but then whenever you add scene up here, oh, so my thing is, okay, let's just go through this example, okay? So our heap, this is the root, so we pop this off, okay? And I'd say heap equals to 1, right? And
Yeah,
then
right.
now we append the 2 and the 999, right? And
Yeah,
then
right.
now we pop up to 2. So I guess the scene is gonna be 1 because we popped it off, right? And now we
Right.
pop the 2, scene is gonna be 2, right?
Right.
And then from 2, we're gonna append its neighbor because this graph is a triangle. We're gonna append 999 again. And when you pop out 999, now we add that to the scene, right? Uh, and then now we pop up this 999 again because we only append to scene whenever we pop it off. But this 999 can be accessed by this 1 and the 2. Because this is the graph is a triangle, right?
Yeah, but okay, but when it's in the scene set, it won't be pushed to the mid heap again, right?
Just the way how you're setting this up is you only push to scene whenever you pop it off, but you're pushing this 999 twice based on the code that you've seen.
Oh, okay.
Because you're pushing this twice, right? Because this never gets popped off until way later. So you have like duplicate nodes inside your heap now.
But hang on, but if I have a condition over here, right? So if the next row and next column is not in the scene set.
Yeah,
So if the not is 99 is already in the scene set, it won't push it to the heap again.
yeah. But you never add this to a scene set until you pop it off. That's the problem, right? I'm trying to show a counterexample where if you have a code like this, you're gonna have duplicate nodes inside your heap.
Okay, so okay, let me try to follow your thought. Okay.
So we can run this code right here, right? So let's say heap is equal to 1, right? We're appending 1 here, right? Cost
Right.
of 1. And our scene is empty, right?
Yeah.
Let's do it like this. Now we pop up the 1. So scene, we add 1. But now this graph is a triangle, so we're gonna add 2 and 999, okay?
Yeah. Right.
And then now we pop off the 2. And then now 2's neighbor is going to be, since 1 isn't seen, we don't add 1, but we add 999 back to the heap, right? Because it's not in scene. And then now we pop the 999. So we pop off the 999 to here. However, we still pop off this 999 again.
Okay.
So you add duplicate nodes into the heap, right? So like I said, like whenever you add something to a heap, you want to couple this operation of adding this to your scene set as well to ensure that you don't have duplicate nodes inside.
Okay. Yeah. I get it now. Okay. Wow. Well, you think a lot faster.
No, I thought
Yeah,
about this edge
yeah.
case before too, so I'm able to articulate them.
No, you're smart.
No, don't say that. I'm not smart.
Well, yeah. So okay. So this is yeah.
So
We
you'll do
push it to the
one
scene.
up here as well, right? You'll do one up here, right? Because you added something
Yeah.
to the heap, you'll couple it with the yeah.
Right. Yeah. So it's gonna be like this. Otherwise, I will miss the first guy. So oh, I call it my heap. Push it to heap Q the push. Yeah, push to my heap, and also push in the coordinate of something like in an array.
Okay.
And also the cost. The cost is gonna be the grid accessing next row and next column.
And then think you should fix heap a little bit. Oh, this part.
I'm sorry, what was that?
Are you this part here? Just copy and paste it, right? When you're
Yeah,
adding
I mean,
scene,
yeah, is it not right? You think?
What do you think, right? You tell me.
Oh, right, yeah. Sorry about that.
It's okay. I think this doesn't add the coordinates. But this is an iterable, so it will be like this will turn into this. So I think I have to like add like another like make it into a list or something.
It's not a tuple.
So it's a tuple, but it's gonna spread it out across scene. So you have to make it like a tuple like this is what I'm saying, right?
Okay, maybe I just make it a list then, like this.
No. This will so if you do like a set of ABC like this, it'll become ABC. If you do a set of AB whatever AB C comma D, this just becomes a comma B C comma D, right? It's different, right?
But what about if I have but what about if I have something like this? So I have only this.
Yes. So this becomes A comma B, right? Because this is an iterable, right?
Oh, okay. Is it? Okay.
Yeah.
Okay.
So you have to like you have to like make the entire thing. You have to like wrap it around into a list or something.
Okay.
Yeah. Or like another way to do it with the comprehension style is like, or if you want to hard code it, you can do this, right? This is not a dictionary,
Yeah.
but this is a set because it has no key value pair. It's just only a keys,
Right.
so you can do it this way too. Whatever you're comfortable with. So yeah. This looks good. So for here for adding, you don't have to do that anymore. For adding, you don't have to wrap it around with the list. You can just make it straight into a tuple. Yeah, only if you initialize it, like
Oh,
here.
okay.
Yeah, that's like the only
Okay.
thing.
Okay.
Yeah.
I didn't know that.
let me try running this code. Okay, it should work because it looks good. um, what do you
I'm not
think?
sure.
What do you think about the problem?
I I don't know. But if at the end, uh,
You should always find a
is it
solution, right?
possible? Yeah, is it possible? Is it always possible to find a solution over here?
Yeah, because you're always popping up because you're pushing every node into the queue, right? So it's eventually it's going to reach the end, right? Because you're pushing everything into the queue. You're just popping off based on different priorities.
Right. Yeah. Let's try. If it doesn't work, and let's call it a day. I'm fine with that.
Yeah. No, I'm confident it works because the code looks very obvious, right? So I'll
Okay.
just so I'll paste it here. Um, I just added like a few parentheses, but it's the same code. I'll give you the problem here. So here's a URL. And then we could talk about it afterwards.
Yeah. Maybe I'm not again. I'm not gonna run your very serious time. It's getting pretty late.
Yeah.
I'm gonna run it myself, and I as long
No,
as
no,
you see
no. This is the code here. No, you're not wasting my time. I mean, there's like nothing else for me to do. Everything's closed at this time, right? So,
okay.
yeah.
Let me try it.
I mean, we can like debrief on like what went well, what didn't go well, what you can improve. I mean, like those stuff. If you're down for those kind of feedback conversations, right? Like,
Yeah, definitely. Okay, it works actually. Oh, it works. Woo. It looks like this.
yeah.
Thank you.
Right, no problem. Well, so
Yeah.
so let's just
What?
go
Yeah,
ahead.
go ahead.
No, go ahead.
What
Yeah.
kind of feedback that the you might have for me?
Like this part here. You're pretty adamant about adding set to here without I guess that's like one. That's like one thing, right?
Yeah,
You can
that's a follow on
every time you do an append operation to your heap or queue, you want to couple it with adding it to scene, right? Because like you can have like a graph um where you can end up adding both like maybe adding the same multiple nodes to your graph multiple times, right?
right. Yeah.
So you had a good intuition for like using a min heap. I think that was good. Um, uh, I wouldn't go with these kind of names though, like temp, where like temp is. I think it's just like a maybe I'll just use like RC, right? Instead of just calling it temp, because like temp usually implies that you use it once and throw away, uh, but like it's just like I mean that's just like a small coding style, I guess. You and
Yeah,
then
probably I should call it like current calls or something like that.
yeah, because I'm
Yeah.
not sure depending on like maybe the company you screen for they may dock you down on that those attentions to detail kind of stuff, right? So
Yeah.
but I mean these aren't like technical errors, so you can like you can always improve on those very quickly. um I guess for here I kind of like guided you on the solution, but so the reason why I asked this question is because I guess like the code isn't too bad, it's not too hard, but I guess they make it hard, like I said before, because there's like you can literally take like five different approaches to solve this problem. Um, I just wanted
Did you
it was for
so did
go
you
ahead.
learn all? Did you learn all five questions?
What do you mean five questions? Do I know
So
how to do all five of them?
five ways. So you learn all five ways.
Yeah, I know how to do all five ways and be able to articulate all of them. But
Oh, okay.
since
Wow.
there are five different ways of doing it, I just want to see like where where I was because we haven't like talked enough, right? To the point where I kind of know where your skill level is. So I was just using this as like a way to figure out, like next time when you talk or whatever, like what kind of questions I should be asking you. So this was maybe a little bit on the on the higher end of the spectrum, but but
Mm-hmm.
but it was still doable in my opinion.
Yeah, yeah, okay.
Right,
Yeah,
right.
yeah, yeah. It wasn't easy for me. Yeah, you're right.
Yeah. Like it was solvable to you if I like kind of like nudge you in certain directions. So that's why I knew I could ask this question to you. Um, I just wanted to see where you were, so the next time, when I come actually prepared, I can kind of know instead of just like kind of like guessing. I kind of know uh like where it's at. Because if I ask like too much
Yeah.
of an easy question, whatever, like it might waste most of our time. So I don't want to do that. But I think this was
Yeah,
like a
next
good learning experience as well. So
yeah, next time when I meet you, I'm gonna ask you two questions as you request, right? And
I guess,
I'm only good with one. I'm only good with one. I'm a
yeah,
bit tired.
yeah, because I know
You want
it's
to?
at the end of the day or whatever. But yeah, so you probably been through a bunch of stuff. But yeah, uh,
Yeah, yeah. If you can, I mean, if I ask you one question, I will ask you
yeah,
multiple ways to solve it. Because
you can do that too.
you
Yeah,
like those. Yeah, you like those challenges. So I see that what you like to do and how you like it. But do you enjoy the person that asked you today? That one was really
that's
popular
fine.
actually.
Cause I don't want to like memorize a bunch of stuff, right? So
Was it
I
was it
still
was it too easy for you? Was it too easy for you? The one that I asked you.
uh no, not really, because I saw if you look at the way how I like keep articulating down and down, I couldn't just go from what I just said down to code, right? I had to like it took multiple I'll just bring up what I said. I'll bring up the comments here. Like it took me like multiple iterations to get to how I want to explain it. So I got from here to here, and I had to like explain all the way down to here to here to here, right? And so like
Okay.
so it was like a multi-step process. I couldn't just go from here all the way to here, right? Because that's just kind of like cheating if I did that. And then by cheating in the sense that is that what is it? It seems like you memorize the solution, right? And the thing is, if I
Right.
approach any problems like this way, I can like literally break down any problem to its like the from first principles, and then just from there you just rearrange the equation such that you get rid of this I to make it like in terms of j, so that you get rid of the inner for loop and stuff. Just and you rewrite I in terms of j, so everything's in terms of j, right? But but yeah, I don't think about questions if it's easy or hard or whatever. Because I feel like if I do that, then I lose the mental edge in terms of like I create these unnecessary mental problems for me. If a problem is, oh, the problem is very hard or whatever, then I'm putting myself at a disadvantage from like a mental game perspective. So I don't think about that stuff. Like if
Right.
it's hard,
Okay.
if I don't
That's
get if I don't get it, then I'm gonna learn a lesson here that I don't get it. So I'm gonna have to like sit down and then kind of like learn what I need to do to get to that skill level, and then that's it, right? I don't
yeah.
care.
That's
I don't
fair.
think about these easy or hard or whatever.
That's
It's like
fair. Yeah. Yeah.
my yeah.
Yeah. Because most people they really look at the levels and look at um yeah. But I know I do get where you're coming from though.
It's just like you're just creating this unnecessary problems for yourself. Because like, well, what if it's like easy or whatever, and then like you actually can't solve it, right? That's gonna kill your confidence. Like, oh, it's an easy. I can't even solve an easy. Look how terrible I am, right? It's just like, no, what do you like? Why are you having that kind of mindset? I mean, this is a separate topic, but yeah, it's just like it's kind of toxic. But yeah, so
Yeah. Fair enough.
so
That's a yeah. That's really good mindset. And okay. Maybe next time you don't like next time when I meet you up, you don't like a Lico interview.
uh, I prefer this because like this kind of like this you cannot just expand and run code or whatever. Um uh
You can do the same thing on Lico though. You can insert the problem to Lico if you want.
I mean, like, what if I want to ask you like non-leak code questions, right? Because I have like different other topics
Oh,
that
okay.
are
Yeah.
non-leak code related, that is interview related, that's not on leak code, but like those are like good interview level problems, I think. And so
Sure.
like
Yeah.
so you're just like limiting yourself to leak code because like leak code is not everything. I don't know, but for here it's more like a Google Doc kind of style where you can't just it's more like a you're just working on a text document, right? There's
Yeah. Okay. Fair enough. Yeah. Yeah.
yeah.
Yeah. Yeah. Yeah. This is exactly what Google Doc looks like. I saw this two times in my. I mean the real thing two times in my life, but I didn't make it for the
And
second round,
so like
unfortunately.
it's like what's that saying? It's like a train like how you fight kind of thing where I don't know. But yeah, it's kind of like that. I
Yeah.
guess yeah.
Fair
Um
enough. Yeah.
do you have any feedback for me? I guess like what
Well, yeah, I'm impressed as always. I actually learned a ton from you again. Um, well,
because like if you want to do some kind of like what is it like if you have like certain problems with like binary search or like the way how to think about stuff like at like a more like a problem solving level I'm down to like talk about those kind of things and then just like flesh how I would think about approaching those concepts as well. So it doesn't always have to like, oh, let's just go for interview prep, solve this, solve that. It's just like you could make the session a little bit more educational if you want to. Like I'm fine with that, right? Because if I'm forced
yeah,
to teach you stuff, that means that I'm forced to be able to communicate better and explain certain concepts in an actual interview as well. So that as a proxy would also improve the way how I would communicate, right? So
yeah.
it doesn't
I
always have
think
to be like,
you
can you
communicate.
solve this? Yeah, yeah,
Yeah, I think the way that you communicate is good. Is the problem is on me that I couldn't. I'm not fast enough to catch you up. That's the
yeah, yeah,
problem.
yeah. Yeah.
I've
That's my
the way that
that's
you.
missing on my communication as well, which means that because I communicate too quickly, I assume that the audience, whoever I'm talking to, may be able to catch up.
No,
So that is my fault
I'm
as well. I need to take
I'm a really
ownership with
bad
that.
interviewer. If you, I think you go for the Google guys, they don't know exactly what you're saying. So I think you are at the right speed because the way that the speed that you're talking fast, making
Yeah,
people think that you're thinking fast and you're smart, right? So I don't want you to like make yourself slower. You just keep on doing that. It's for me to work on my speed up to think faster. So
yeah.
I like the way you talk and communicate. If I don't understand, I just say, "Oh, I don't understand." I ask you to say it
Like,
again.
that's good
Uh,
too, because like it
yeah,
exposes what my assumptions are with respect to who I'm talking with, and so I think it's that I can take away from that as well. That's pretty good.
yeah. Also, I really like it that another thing is I mean you have done really well was you went straight for the brute force and also
Yeah,
you quickly came up with a big O for the brute force. So it's
yeah.
and this is something that I would ask anyway if you don't say it.
Right, right.
Um, and then yeah, I there's nothing bad that I can say about the approach you have done, and
So
I'm still
so the
impressed
way
and
how I wanted
amazed.
to analyze my time complexity is what are the number of states, right? Number of possible things. Uh, it's like a chemistry thing. Number what is the number of states? I guess I'll put here. And then we put and then work done per state, right? So time complexity is so it's number of states times work and then per state. So these kind of get these kind of get crossed off. You like multiply them, so you only end up with work, right?
Yeah.
Yeah. So it's like so for the brute forcing, the way how I got it very quickly is how do you generate all possible subsequence, right? Subarrays, right? It's like entries to right. Entries to number there's like entries to number of points plus n because each point could be itself, right? And then so let's say like these are all the ij's. And then so what is a work done per state, right? So work done per state is sum of nums of I to j, right? And this is O of n, right? So this is like n squared already times this is n squared here times n, right? And it's gonna be n cubed, right? So that's how I like kind of see
Yeah,
it. Yeah.
yeah. That's why I was asking why it's not n square because I in my mindset I know that it's gonna have a double for loop and then there's something inside it takes big
It's
of
the
n
work
to do
the
it.
work is O of n, right? So
Yeah, exactly. When you times together, it piles up.
So this is how I like to like stay consistent with the time and space complexities. Okay, how many? What are the number of states? And then what's the work done per state? And then you just like multiply them together, and then that will be the total time. That's how I like to model the time complexity analysis.
That yeah, yeah, I'm yeah, that's I'm impressed again.
Don't say don't say that. It's gonna make me complacent. I'm kidding.
Well, yeah, I think yeah. Okay, I think it's
Yeah,
getting
so,
pretty late.
yeah, it's still late, but
I gotta go. Yeah, I think we
but
have
yeah.
done amazing work today, and
Do
let's
you
meet
want
up
do you want
again.
to continue this on next Thursday? Do you think you can make it
Yeah,
on 8? Because right now it's 9 is a little bit pushing it. So do you
wait,
think next
what
Thursday you'll be able to do 8 p.m. again, or do you
8 p.m.
think
your
even?
time or my time?
I mean, we're on the same time. We're on West Coast PST.
No, my time right now is 11 o'clock.
Like you're 11. Or is it 11:40 or are you 10:40?
Yeah, I'm 11:40.
Oh, you're 1 hour. Okay, okay. I was like, I thought
Yeah,
you were on the West Coast time too. Okay, I
no,
see.
no,
I see.
I'm on the province next to Vancouver.
Yeah, yeah. Oh shoot. I thought. Okay, okay. Sorry, my bad.
So what time do you prefer actually?
We can do 7
You
p.m.
said say
PST
your
or 8 p.m. PST. What do you want?
let me see. So let me read your pack. So it's 7 p.m. PST.
Or 8
So
p.m.
that is 8 o'clock 8 p.m. Alberta.
Yeah. Yeah, you're just 1 hour ahead of me. Yeah, yeah. So what?
Or
8. So today was scheduled for 8 p.m. Right? 8 PST. Today was 8 PST, right? Or like a 9 Alberta. But then you had the office
yeah,
hours,
or it's
right?
yeah. Unfortunately, the 9 o'clock I had a office hour,
So,
and
so, so do you think it's gonna be a regular recurrence for you to have these 9 p.m. Alberta August 9 p.m. So what I'm trying to say is will we have these regular 9 p.m. office hour times,
yeah, the I mean it's not my time. It's the TA's time. He
or
set it the time.
or do you think that's usually the pattern that's gonna happen every week? If it is,
Yeah,
if
he
it is,
decide.
then we can push it to Friday. So
Um, well, let's try this time. Let's try the 8 p.m. at 7 PST and 8 p.m. Alberta time.
because the thing is if you have the problem with that is if you have a 9 p.m. meeting, right? Then we can only talk for like 30 minutes each, right? And we have to like rush it.
Okay.
And I don't
So
want to rush this, right? So
what time what time do you have time at Friday?
so Friday I'm good. I'm
Maybe
good
let's try this
whenever.
time on Friday. Yeah, let's try this time on Friday. How's that?
That's fine. Yeah, that's fine. So 8 p.m.
Yeah.
PST on
Oh,
Friday. Yeah.
yeah. I'm okay with whenever it's time. I don't have nothing to do on Friday actually.
Yeah, because the thing is if you do this like we said, this 9 p.m. thing might come up, so we just have to like cut it short. So it's gonna be awkward. So
Right,
um
right, right. Yeah, I don't want
yeah,
that as well. I want to chat with you a bit more.
yeah.
But what I'm afraid of is well, you're a lot better programmer than I do. I'm afraid that you're not learning when you're talking to me though. I'm afraid of that.
No, no, no. You don't have to worry about that because the way how I would approach it is if I can explain it well, that means there's like a hole in the way how I think about stuff and how I communicate it. So that's where that's like a metric of improvement for me. So
Right.
so
Okay. Good.
although I may not be technically be learning something novel, there are ways in which I can optimize my performance, right? So you don't have to like worry about that stuff because I would
Okay.
yeah.
That's good to hear. I just it's my concern that I'm afraid that I'm wasting your time. That's why. Anyway,
Like if you're wasting my time, I'll let you know that you're wasting my time, right? Because like yeah, so yeah,
that's
because like
fair. Yeah. 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 I
because for here when I was
I
doing
like that.
this, yeah, there were certain steps where I kind of improved as well, and then so it's not like I'm not taking away anything out of it. So you don't have to worry about that stuff.
Okay. Okay. Yeah. Yeah. Let me
Yeah,
know if you
yeah,
saying yeah.
I'll let
And
you know.
okay.
Yeah,
Let's meet up again next Friday.
okay,
Um. and then and as usual, I will email you,
Yeah.
and then we can sit down and then do it again. I'm gonna ask you two questions next time.
You can ask two, three, whatever. It doesn't matter. Oh, like yeah, because like we can ask about like certain concepts or certain ways of think, or you don't have to ask me any of those, right? You can ask me like, how do you think about approaching this and this problem, or how do you want to formulate this and this problem, or whatever. So it could be more of
Yeah.
a discussion than having to like, oh, answer this, right? It's just like that. That's just kind of like wasting my time because it's like, am I circus monkey to you? Are you putting on me a performance, or whatever? Because I've had these. No,
Oh
literally,
man.
I've had this.
Oh shit. 2 hours.